questions about your homework? It's Friday. Let's knock it out. Do you have other classes where you don't do anything? No. No. Can we what? I'm sorry. No. Okay, questions about your homework. Y'all okay? I heard y'all say, oh, this is easier than what we've been doing. Yeah? No? It feels harder? Oh, it feels too easy? Do you make these sandwiches every day? Yeah? You do that by yourself? Your parents don't do it for you? You get up and make yourself a sandwich every day? Is that your breakfast or your lunch? That's your lunch? You just eat it this early every day? Don't you get hungry? Oh, you just have multiple lunches. Just wondering. All right. So no questions. We'll move on then. Why? I feel like I ran the wrong. Oh, I did. I ran the We're actually going to push through 2 lessons today. It's 2, but it's not 2. In Algebra 1 is 2 lessons. In Algebra 2, we do it as 1 lesson. And you'll see why whenever we get there. So I've got quite a bit to cover with you, but none of it's super duper hard as long as you stay with me. I'll tell you what to do for each one, okay? Y'all ready? No? Fine. You gotta use your brain. You ask me every day, can you have a brain break? Before you even use your brain. All right, imaginary numbers. Tell me what this equals. Y'all are half right. Plus or minus 2, right? I got to have that negative because I got to be able to take both the positive and the negative values there. But what if I did this? Why is that not possible? Because, right, y'all are exactly right. By definition, we said something times itself twice gives me -4, but there's nothing you can't multiply by the same thing and get a negative, because 2 negatives make a positive, 2 positives make a positive. I would have to have different signs, right? So here's what I do. I say, well, I'm going to make up this little imaginary number I, and I'm going to say, let's let I be the square root of -1. Since I can't do that, right? Since I can't do it, let's take that out of the picture. So let's say, all right, let I be the square root of -1. Then could you tell me what the square root of -4 is? 2i. That's exactly right. If I take it, because remember, if I do it like this, right, then that would be the square root of -1 times the square root of 4. And I said, let this replace -1. Okay, so here's in general. Okay. Number 1, you need to know that I is the square root of -1. Number 2, if you ever see a negative under a radical, drop it. Oh. And put an I outside. That's what you need to know about I so far. Two things. I is the square root of negative 1. And if you see a negative under a radical, drop the negative off and just put an I outside. That's all you need to know right now. Yep. I is always the square root of negative 1. That's what I always is. Kind of like pi is always 3.14159, right? I is always the square root of negative 1. So now that you know that, show that up. That's one of probably about 5 or 6 things I have to say. But let's look at this real quick and make sure you got it. What does that equal? Plus or minus 3i. We still got to do those plus or minuses, okay? Be careful with the plus or minuses and where you put them. Remember, we don't want it to look like we're adding or subtracting things. We want to put it out front. How about this? I'm fixing to crank it up. Y'all know I always got to make it a little bit harder. Simplify the radical. Tired? Did you win yesterday? Congratulations. Dominated. Did you do that on purpose? Did you know that? Did you know that's what would happen? But you knew that would lock his shoulder in place like that? Oh. Is it what? What'd you get? Even a bigger one then. You could do, that's fine, and then you keep going with it. What'd y'all get? How did y'all get that? What 2 did you break it up into? 16 and 2. Remember, the very first thing I'm going to do is just bring this out, make that an I out front, and then I'm going to do the 32 like usual. So in general, if we have all the components, we have a coefficient in front, we have a radical, we'll do the coefficient, we'll do I, and then we'll do the radical, and the plus or minus goes in front of all of it. If you have no radical, we just do the number I with a plus or minus. So just una más. One more. I took 4 years in high school and know it, but that's about all I can say. What did he say? What, una más? What? That means let's go, doesn't it? Did you really? That's what my husband wanted my children to learn that. Because he says that it's going to be like worldwide, that's going to be the big language. That's what he said. All the way.
mean, when I was in Texas, they made us learn it in elementary school.
He is. I wish I was fluent. All right, what'd you break it up in? 64 and 3. Nice. So what does this simplify to? 8i root 3. There you go. Okay. Everybody okay? Speak now, forever hold your peace. No, you don't got it? You don't? You don't have to. Me either. Look what I do for a living. Okay. Let's do what we did yesterday. I think this was yesterday. What did we do yesterday? Yeah, solve with square roots. Let's do what we did yesterday and see what happens if it becomes solve. Solve and simplify. Mark, set, go. Mm-hmm. How do you know that this is a regular solve and not a factor in solve? Look at y'all go. X is only in there one time, so I can sad map my way out of it. Y'all are so smart. It stays under the radical though, so you just put the I in front, yeah. I'm going to go ahead and subtract this 15 and get 4x squared equals negative 24. Divide by 4. Now what? Square root it. There you go. That's all you can do, right? How do you know you can't do anything else? There's nothing I can do this with, right? Because one of those two numbers, whenever I do this, has to be a what? Perfect square. There you go. So since that one doesn't have a perfect square, I'm going to leave as is, but I am going to pull the I out because I don't want to leave the negative, and I'm going to throw the plus or minus in front. Easy? Sure? That's not all. Almost halfway done. Yeah, we have homework. Y'all thought we don't have homework on Fridays? Y'all are silly. Yeah, we have homework. But just like every other day, I try to give you time to do it in here. I try to let you do homework. All right. Powers of I. This is probably the most confusing. After this, we'll be halfway through with the lesson, but this is probably the most confusing part of the whole lesson today. What I tell you I equals? Square root negative 1. Everybody okay there? Thank you. How about I squared? Negative 1, right? Remember how we talked about opposite operations yesterday, and we said this and this will always cancel each other out? So if I square this, what am I left with? Negative 1. Everybody okay there? What if I do I to the third? Negative I. I'm going to take this one and multiply it by I again. So negative 1 times I, and so I just get negative I. Okay. It's going to be negative I. This is what, and I'm writing this equals I. I know that it already says that, but I'm showing you what we're going to substitute when we see these things. If you don't understand, this will all come full circle in just a second. Just stay with me. How about I to the 4? positive 1. And let me show you why. If I take I squared and I square it again, what do you get? Positive 1. Now, if that does not make sense to you, it is okay, but you do need to memorize those 4 values, okay? I, negative 1, negative I, and positive 1, okay? Because what happens if I do I to the 5th? It goes back to regular, right? If I'm at 1 and I multiply by I again, I'm back at I. I told you this was the most confusing part of the whole lesson today. What if I multiply by I again? Negative 1. What if I multiply by I again? What if I multiply by I again? What do you notice? There's a pattern. It's what we call iterations in math. Once it hits a certain loop, it just keeps looping and looping and looping and looping and looping. So essentially, I could find any value of I that I wanted to just by knowing the first 4. How might I do that? Well, what if I asked you, what is I to the, let's say I asked you I to the 17th. Tell me what you're doing. Walk me through what we're going to do. Multiples of 4. So how many times does 4 go into that? 4 times, which is 16. And how many are left? 1 is left. So where am I going? I. Good. So look, here's what I'm going to do. If you're the kind of person that doesn't like to think through and reason through, like I'm a reasoner. I like to know why things happen the way they do, and I like some of you just say, just tell me what to do and let me do it and be done with it. If you're a just tell me what to do and let me be done with it, here's what you do. Take this exponent, divide by 4. The remainder tells you what the answer is, okay? If you get a remainder of 1 when you divide, which means if you divide on your calculator, it ends in 0.25, then the answer is I. That's right. If you get a remainder of 2, that means you're on the second iteration. That means it ends in 0.5, then it's negative 1. There you go. Remainder of 3, or 0.75 if you're using your calculator, gives me negative I. And then of course, there's no remainder. So it just goes in a whole number of times. Then it's just 1. So what would I to the 125th be? I don't know. I got to do it. What's 125 divided by 4? 0.25. $125 divided by 4. What'd you say it was? Because it's 0.25, then this is the one I go with. Does that make sense? Everybody okay? All right, then I'm going to move on to complex if y'all ready. Y'all need to stand up and stretch real quick. Always divide by 4. There's always 4 iterations. Y'all need to stand up and stretch? Okay. Stand up and stretch. Good. Is it hot outside? Hot. All right, complex numbers. Here's what a complex number is. It's made up of 2 parts. It's got a real number part, and then to that real number, you either add or subtract an imaginary number. Together, they make up a complex number. So it might look what? it might look something like 2 plus 7i. 3 minus 5i. These are all complex numbers. See how they have two parts there? Not just one. So if I told you I had, I don't know, 12i, is that imaginary or complex? Imaginary. Do you see the difference? This is complex. Yes. This is imaginary. Now I say that because there's going to be a difference we're going to have to determine whenever we get to dividing, if I'm dividing by a complex or dividing by an imaginary. And it's going to make a difference on how I simplify it. All right, so what I got to run through with you, so you know, I told you this is a loaded lesson today, and since I'm not going to see you Monday, we got to get through it. Most of Monday. I'll miss you for an hour Monday. Sophomores have Johnson's meeting, yeah. They're going to try to get you to buy one. Right. Addition, subtraction, multiplication, and division of complex numbers is what I got to show you. So 4 little things. We're going to do addition, subtraction together. Multiplication is easy. Division is hard. Okay. So we just got to get through it. This, again, remember I told you everything is solving quadratics. This is going to come up whenever we start solving. We'll get complex numbers and imaginary numbers, and we'll have to simplify it. So, yeah. But not today, not today, not today. Today, we're just going to work with these numbers. All right, here we go. I told you addition, subtraction was first. I am not going to camp out here long because it is so easy. If you can combine like terms, you can add and subtract complex numbers. In fact, I'm going to put that here. Combine like. Be careful that you look at what is going on, okay? So I might have something like so say that again. Yep, that's exactly right. I just look at the like terms and combine them. That's all I do because I'm adding here. This is not multiply, this is add. Notice the sign in the middle. So 7 and 9 give me 16. And then I have negative 2i and 5i, which would give me what? 3i. Are y'all okay with that? Easy? What if I change it to subtraction? So instead of 7 minus 2i minus 9 plus 5i, what's the difference here? How am I going to go about solving that differently? That's exactly right. If you're a same change kind of person, I could do same change all the signs in here, or you could just look at it and know I'm subtracting in the middle instead of adding in the middle, right? So I've got 7 minus 9, which would give me what? Negative 2. And then I've got negative 2i minus 5i, which would give me what? Negative 7. Addition, subtraction, how do you feel? If you're good, I'm good, and I'm going to move on. Okay. Let's do multiplication then. For multiplication? No, but for division, yeah. I'm sorry to do such a loaded lesson on a Friday. None of it's really hard, it's just a lot. I'm not. I love math. You what? Again? Okay, well, he's officially ahead of me now, so I feel better. Is it? Somebody tell me what to do. What are you doing? Why are you doing that? Tell me what process you're using to multiply. Distributing. I'm going to distribute. Some of you call it FOIL. I call it distribute. I'm going to take the first term and it's going to distribute to everything here. So 2 times negative 5 is negative 10. 2 times negative 3i, negative 6i. Treat that I just like an x as you multiply through. I'm done with that one. I'm going to move on to the negative 4i. Negative 4i times negative 5. Positive 20. That's exactly right. I. How about negative 4i and negative 3i? It'd be positive 12i squared. Now, what did we say about I squared? It's negative 1. So make yourself a note. I squared drops and changes the sign of the number. In other words, this is not 12i squared. It's really, why does it keep doing that? It's really negative 12. Okay? Now gather your like terms together. It's just, it drops off completely. It becomes negative 1, and so that just changes the sign of the number. Yep. On an I squared. That's what I squared does. If it started out negative, so if it was like negative 3i squared, that would become positive 3. But because it was positive 12i squared, it just becomes negative 12. Every time. Every single time. Close. Watch your signs. Look at your real numbers. I got negative 10 and negative 12. What does that give me? Negative 22 plus 14. Oh, I'm sorry. Sorry. Oh, yeah. Standard form of complex, we always write the real number first and then the imaginary, but it's not wrong. It's not wrong that way because addition is commutative. I can do it in any order I want to do it, so that's fine. All right. Y'all ready to move on to the hard one? And I will be done. That's my cat. And on business up here. Is that what he said? Man, great. Okay, I'm just kidding. Kinsey gets so embarrassed. Okay, division. I'm going to break this into 2 different parts. I'm going to do division by imaginary, and then I'm going to do division by complex because they're a little bit different. Y'all ready? No. Just go anyway. Okay. What's the difference in an imaginary number and a complex number? That's exactly right. Complex is made up of a real number and an imaginary. A pure imaginary just is something I. That's it. That's the only difference, okay? So if I'm dividing by just something I, let's say, for instance, 4 over 9i. Remember how whenever we were dividing by radicals, we said, oh, you know what? You can't divide by a square root in the bottom. Remember that? And how did we get rid of it? Multiply the top and the bottom by that, right? Well, here, wouldn't you agree that there's a radical in the bottom even though you don't see it? Why? I is a radical, right? So I need to get rid of it. So if you see this, I'm going to use that same process. I'm going to multiply the top and the bottom by I. Because that is the radical that's in the bottom, yes? Say yes, because that's right. Okay. This would become 4i over 9i squared. But remember what I told you just now. If you ever see I squared, drops, changes the sign. So really, this is 4i over negative 9. Do what? That's the answer. Easy enough? Okay. Oh, yep. We're to the last thing, y'all. Praise the Lord. Yep. Monday. It's going to be 2 sheets, but we're just going to do half of each sheet. So it'll be 1 sheet. The homework. All right, let's do dividing by complex. This is the hardest thing we will have done today, besides the iterations. And I know this is a lot, and I'm sorry. I know, I'm sorry. I'm sorry, y'all. I'm sorry. All right, dividing by a complex. For example, 7 plus 3i over 2 plus I. If I just multiply by I, top and bottom here, the I is not going to go away. Okay? I think I'll just tell you, instead of taking the time to explain why and how and what, I'm just going to tell you what to do. Complex numbers have what we call a conjugate. That just means that the middle sign only changes. Nothing else, not the first sign, only the middle sign. And what happens when you multiply conjugates together is the i's disappear. Okay? So what I'm going to do is I'm going to multiply the top and bottom by the conjugate of the bottom. I'm going to give you a second to catch up with me before I actually do it. Oh, I've been doing problems off your homework. I thought I had a different sheet. It's too late now. All right. Tell me what you think the conjugate of the bottom is here. All right, look what it says conjugate does. Read that again. Okay, so give it to me as the whole thing. It would be 2 minus I. That is the conjugate of the bottom. Multiply the top and bottom by the conjugate of the bottom, so I'm just going to do this. This is only hard because it puts me in a FOIL situation twice a lot of times. If you want to, you can. I usually just leave it and I just start multiplying out. 7 times 2. Yep. Minus 7i plus 6i minus 3i squared. That's the top all FOILed and multiplied. Right, and I'm going to go through and change all those, yep. Then on the bottom, I get 4 minus 2i plus 2i minus I squared. And so you're exactly right. I'm going to go through and I'm going to change all my I squareds. This is not going to be negative 3i squared anymore. It's going to be plus 3. How about negative I squared? Plus 1. That's exactly right. And now the magic happens. We're just going to simplify the top and simplify the bottom, and then we're going to leave it alone. So up top, 14 and 3. 17. Negative 7i and 6i. Negative I. I'm done with the top. I've got an I still in top. Is that okay? Yes, I can have it in the top. The bottom's the problem. Now look at the bottom. 5. What's that it? It's negative 2i and positive 2i. If you did it correctly, you won't have an I in the bottom anymore. Right.